Okay, I was to do problems 6 and 7 and 8 tonight. And in order to do those problems, we're going to need a couple of things. We're going to need, first of all, that chart that's at the very bottom that tells us the solubility rules. And we're also going to need access to those problems. So I'll toss those up on here and walk you through them. So first one says that we have K3PO4, which is aqueous. So we know that we're going to separate that out. And we're going to have K plus and PO4 minus 3. And we're going to have 3 of the K pluses to balance out the PO4 minus 3. And then we've got aluminum nitrate, so that's Al plus 3, and 3 NO3 minuses. Okay, so what's going to happen here is that the K, which was originally bonded to the PO4 minus 3, could bond to the NO3. So we're going to see down here, and we're going to say, oh, well, the first rule says that anything that's in 1A is soluble. Well, that's K. That's in 1A. So I know that no matter what K is bonded to, it's going to separate. So I got K plus and NO3 minus. Okay. And then AlPO4, well, let's see if that one has a rule here. Well, the first one doesn't have a group 1A, it doesn't have ammonium. Nitrates, chlorates, and acetates. Well, this and this isn't a nitrate, chlorate, or potassiate, or acetate. Halides, not a halide. Halides are this column here. Sulfates, not a sulfate. Carbonates, phosphates, and sulfite are insoluble except 1A and ammonium. Okay, so that tells us that this is going to be our solid. And you might be wondering, over here we've got 3K plus, and over here we just got 1K plus. So we're going to say this is 3K plus. And NO3 minus, well, we got 3 and 3, so that means that we got 3 of each. We've just got 1 PO4 minus 3, PO4, Al plus 3, Al. One last step here says that K plus is on this side and on this side, so they really don't do anything. NO3 minus, we got 3 of them here and 3 of them here. So realistically, this equation basically comes out to be Al plus 3 plus PO4 minus 3 is equivalent to AlPO4. This is what we call a net ionic equation. I don't necessarily have expected that. I would have expected all of this, though. Problem 7 says that we start with beryllium iodide solution. So that means that we start with, if I can write, Be plus 2 and 2 I minuses plus copper 1 sulfate. So this is Cu plus 1 and SO4 minus 2. Oh, I forgot on the last problem, too, to put AQ next to all these, but I hope that we know that. Okay, so now I got basically beryllium sulfate and copper iodide. So I'm going to go in order here. Rule number 1, we don't have a group 1A, we don't have ammonium. Nitrates and chlorates and the acetates. Nope, got none of those. Halides, all of them are soluble except copper 1. Oh yeah, we got a copper 1 right here, so that's going to be Cu, and I is a minus 1, so that's Cui. This is my solid. Plus, let's just make sure beryllium sulfate. It says that sulfates are soluble except barium, lead-2, and strontium. Well, that's definitely not one of those, so Be plus 2 and SO4 minus 2. And I think that we need to balance this, we need a 2 out in front of here because we got a 2 there and a 2 there. So, if you think about it again, beryllium's the same on both sides, sulfate's the same on both sides, and so I end up with 2Cu plus 1 plus 2I minuses. goes to 2 CuI solids. And then realistically, the 2's can all drop out because it's a 1-to-1-to-1 ratio. And the last problem is nickel 3 nitrate. So let's start with that. Nickel 3 nitrate solution. And its solution, so these are all AQ, plus KBr. K is a +1, and Br is a -1. Okay, so let's take a look. We got Ni plus 1, or K plus 1, and NO3 minus 1. I'm going to get rid of that one real quick. All salts of group 1A and ammonium are soluble. So that means that K stays a +1, and NO3 stays a -1. So these stay aqueous. So even when K meets up with NO3 minus, it doesn't do anything. And then the only other thing I got to check on is do Br -1 and Ni +3. All right, well, I got a rule about halides, and Br is definitely one of those halides right over here. Halides are soluble unless silver 1, copper 1, lead 2, and mercury 2. Huh, well, that's none of them. So that means that the Ni +3 and the Br -1 are going to stay apart as well. And since I started with 3 on this side, I'm going to need a 3 on this side. And that's it. Now, the reason that we say that this is no reaction is because, look, Ni stays Ni, +3. NO3 -1, 3 NO3 -1. K plus, K plus. Br -1, Br -1. So we say that all of them stayed ions. In other words, water kept all the ions apart even when there was a bunch more ions in there. Hope that helps. See you tomorrow.